So hello students, in this video I am going to discuss the relation between simple harmonic motion and uniform circular motion. So this is a quick recap of what you have already studied. So this video is basically meant for students who are preparing for NEET and JEE 2018. Now as you know that suppose a particle is moving in a circular path and these are the two diameters. So basically if the particle is at suppose this particular point, this point P, then I can drop two normals along the two diameters. Now this point and this point, they are called the projection of P. So this is suppose this point A, this point B, so this B, so B is called the projection of P along this diameter, A is called the projection of P along this diameter. So as the point P moves in the upward direction, A will move and P will come like this. So basically as the point P moves in the circle, the projection moves along this diameter. Similarly, if I take this projection, so it will move like this, it will move like this, move. Okay, so the projection will move in this, so it will oscillate in this direction. So suppose if I take this as x-axis and this as y-axis, and at this particular moment, suppose at time t, particle is a point P. So let's say this angle is marked as omega t plus phi. Okay, so basically simple harmonic motion, we say that simple harmonic motion is projection of uniform circular motion along one of the diameters. So omega is the angular velocity of this particle P. Okay, so for this case I can write the equation of the particle undergoing motion as x of t is equal to a cos omega t plus phi. So now in this case a is the amplitude. So for this circle a is the radius. And for the motion it represents for simple harmonic motion it represents the amplitude. Okay, so this is the basics of the relation between simple harmonic motion and uniform circular motion. Now talking about the phase, this is the phase, phi is called the initial phase, omega t plus phi is the phase. So what is the basic concept behind this phase? Let's see that. Phase. So again let me draw a circle. Now suppose the basic thing regarding this phase, this phase is the angle. Now the important concept about angle is if I measure the angle in anti-clockwise direction, it is taken as positive, and if I measure the angle in clockwise direction, it is taken as negative. Now suppose at t equal to 0, the particle is at this particular position. Now remember this cos omega t plus phi. So omega t plus phi is the phase and phi is the initial phase. This is called the initial phase. Initial phase. What do you mean by initial phase? Phase at time t equal to 0. So if I substitute in this relation in omega t plus phi, if I substitute t equal to 0, I get phi. The entire thing is called phase. Phi is called the initial phase. So at t equal to 0, the phase is phi. Okay. Now suppose this is the position at t equal to 0. Now it goes from this position to this position t equal to t, and suppose this angle, this additional angle is omega t. So it is moving with angular velocity omega. So that means the total angle from this reference line. Now this is called the reference line. And this is called the reference circle. So the total angle, this total angle is this is phi, this is omega t. So total angle is omega t plus phi. So this is the total phase. Now let us take one more case. Reference circle, reference line. This is the reference circle. These are the reference lines. Now in this case, now as I told you, if I see angle is measured in anti-clockwise direction, it is taken as positive. So angle taken in clockwise direction will be negative. So let's say at t equal to 0, this is the position. So this is the initial phase. So this is now, say angle is measured in clockwise direction, so it will be negative. So this is phi. Okay. Now it goes from this position to this position. This is t equal to t. Okay. So it goes from this position to this position in time t with angular velocity omega. So this is how much? This is omega t. Okay. Now what will be the total phase in this case? It will be omega t, and this is phi. So it will be omega t minus phi. Omega t minus phi. So this is the phase omega t plus phi. This is the meaning of omega t plus phi when we have omega t plus phi. This is omega t minus phi. Now let us take a problem based on this concept. Okay. Now let us take a problem based on this concept. Suppose at t equal to 0, mass m is stuck, giving it an initial velocity towards positive x-axis. Okay. Now the displacement equation for the particle is x is equal to a cos omega t plus phi. X is equal to a cos omega t plus phi. Okay. Now at t equal to 0, the particle is at origin. Okay. So at t equal to 0, x is equal to 0. So if I substitute these values over here, x is equal to 0. So 0 is equal to a cos omega into 0 plus phi. Okay. Now this gives 0 is equal to a cos phi. So this implies phi is equal to plus minus pi by 2. So phi is either plus pi by 2 or it is minus pi by 2. Now this is the equation for displacement. Now what will be the equation for velocity? Now velocity is dx by dt. So that is minus a omega sine omega t plus phi. Okay. Now remember, in this case the particle is stuck and it is moving towards positive x-axis. So the velocity must be 0, greater than 0. So v is greater than 0. Why? Because at t equal to 0, block moves towards positive x-axis. Okay. So velocity at t equal to 0, if I substitute t equal to 0, I have minus a omega sine phi. Okay. Now if I substitute phi, see the value of phi was plus minus pi by 2. Now for phi is equal to plus pi by 2, v at t equal to 0 will be negative. And for phi is equal to minus pi by 2, v at t equal to 0 will be positive. So that means what is the value of phi? The value of phi is minus pi by 2. Okay. So in this equation, if I substitute the value of phi, so this is the question. In the question they can ask what is the value of the initial phase, or they can ask to frame the equation. So if they ask to frame the equation, then the equation will be x is equal to a cos omega t minus pi by 2. So this will be the answer, pi by 2. Okay. So this is one example. There are few more examples which I will give in my next video. So if you have doubt on the concept discussed in this video, you can post in the comment box. Thank you.